Good morning, pre-calculus. Today we're going to do 2.2 semester 2 APEX version. So we're still talking about sinusoids. Today we're going to talk about tangent of x. So just like we did with sine and cosine, all I'm going to do here is I'm going to graph tangent of x. So when my angle x is 0, my tangent, remember, is going to be y over x, or sine over cosine. So that's going to be 0 divided by 1, which is 0. When my angle is pi over 4, it's going to be root 2 over 2 divided by root 2 over 2, which is 1. Pi over 2 is 1 divided by 0, so this is undefined because we cannot divide by 0. So pi is going to be 0 over negative 1, which is 0. 3 pi over 2 is going to be negative 1 divided by 0, which is undefined. And then 2 pi is going to be 0 divided by 1, which is 0. So here, we only did 1 pi over 4, and we're going to have to do 1 or 2 more here in a minute so you can see what happens. But let's go on ahead and let's draw these undefined values in. So these undefined values, remember, are asymptotes. Okay, so they're values where x cannot be a value. It doesn't happen. It's an asymptote. It doesn't ever touch it. So pi over 2 is undefined. So that's an asymptote. And 3 pi over 2 is undefined. So that's an asymptote. So now what I'm going to do is I'm going to plot the points I know. So I know 0 is 0. I know pi over 4 is 1. I know pi is 0. And I know 2 pi is 0. Well, I don't have very many points to go on there, so I'm going to add a couple more points on. So here, I'm going to add maybe negative pi over 4 in. If I do negative pi over 4, so that's starting here and going negative pi over 4, that's going to be negative root 2 over 2 divided by root 2 over 2, and my answer is going to be negative 1. Okay. Negative pi over 2 is going to be another asymptote because it's negative 1 over 0. And so now, remember that if I have asymptotes, that means that these functions get really close to those lines but never actually touch them. And remember also that these are periodic functions, so they're going to repeat. Okay, so we don't have to find all of the values for it if we know they're going to repeat. Okay, so this is going to be your tangent function, and it's your parent function, so you want to memorize this, okay, because that is going to help you with everything else. Okay, so let's take a look at some of our things here. So with this parent function, we know that our period is where this repeats. Okay, so it starts here and it repeats there. Okay? Or you could say, you know, from here to here. No matter what, that distance is the same, and that distance is pi. So unlike in our previous lesson where we found a period when we stretched or compressed, the period for a tangent is going to be pi over b, okay, instead of 2 pi over b like sine and cosine were. X can never equal pi over 2, and really it's pi over 2 plus or minus pi n, okay, because from negative pi over 2, if I add pi, but I could still add another pi, right? Or I could subtract a pi, or I could subtract a pi however many times. And my range here is from negative infinity to infinity. Right? It starts down, 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 and it goes high, high, high. Okay? So that is my parent function for my tangent. So make sure you memorize this one. And once again, you don't want to have to do a table every single time you do this. You want to have this memorized so you know what the parent function looks like, and then you can work from there. So let's go ahead and take a look at tangent of x over 2. Okay, so this is 1/2 x. So my b value is 1/2. So now I'm going to go on ahead and I'm going to say my period is pi divided by 1/2, which means that my new period is 2 pi, because remember, I never divide by a fraction, I multiply by the reciprocal. Okay, so 2 pi. So then this thing is going to start here, and it's going to continue again there. So my asymptote is directly in the middle of that. So my asymptote now is going to be at pi. And now I'm going to have my values here where I'm going to go on ahead and move this thing around. Okay. So let's see, let's go on ahead and take this out. Okay, so I stretch this thing out, and now my pi over 2 is going to be up here, and that's going to be down there. And that's all just from knowing what my parent function looks like. Okay, I know that between the asymptotes, exactly in the middle, it's at 0. And then the quarters are at -1 and 1. Okay, so same thing here. I know that's at 0. And there's my new asymptote. This will be -1, and this is going to be +1. Then I can just sketch that graph in there. So memorize what those parent functions look like. All right, now let's go ahead and let's take a look at this next one. So this next one says -3 tangent of 2x. Okay, so now I have a couple of things. So my amplitude has changed to 3. I'm reflecting this thing over the x-axis. And I'm compressing horizontally. Remember, it looks like a stretch, but it's really a compression. So pi over 2 is going to be my new period, because it's pi divided by my b. So I know then from here, I'm going to only be going pi over 2 distance. Okay, so there's 2 ways I can look at this. I know that originally my asymptotes were here and here, but I'm squishing this and dividing it in half. So my new asymptotes are going to be here and here. Okay. Well, now my amplitude is 3, but I'm reflecting this. So now instead of it going this way, it's going to go down. So it's going to start at 3, halfway between, and go down. And I could get this by plugging values in too, but if I know my rules, I don't have to worry about that. Okay, and then I'm just going to draw it repeating because it's a periodic function. Okay, and it repeats over and over again. So it's a reflection of that. It's skinnier and it's taller. Okay. Let's go ahead and draw 1 or 2 more in. Okay. So that's a distance of pi over 2. And that's my period. And I've got my points here. All right, so now let's look at cotangent of x. Okay. So we know what our tangent is. So if we draw just a table, and we're going to do our tangent of x, okay, and then we'll go on ahead and find our cotangent of x. And I'm going to start at -pi over 4. Okay, we know at -pi over 4, okay, our tangent of x for our parent function. All right, so if we're looking at our parent function, -pi over 4 is -1. So that's -1. Then we have 0, which is 0. Pi over 4, which is 1. Pi over 2, which is undefined. Okay, and then it repeats. So now for cotangent, that's going to be 1 over that value. So what's going to happen here is this is going to become 1 over 0, which is really going to be our undefined values. Okay. And then our undefined was really, so that pi over 2 was really 1 over 0. So that's going to become 0 over 1, which is 0. So these two are going to swap places. Okay, so now I can graph this thing. Okay, so I know that my undefined is at 0. Okay, tangent and cotangent are inverses of each other, which means that the period is still pi. And now I can go ahead and graph this. So negative pi over 4, okay, is going to be negative 1. Pi over 4 is going to be 1. Pi over 2 is 0. Oh, so if we did 3 pi over 4, remember I said it's inverses. Okay. So same thing here. So we're going to go there, there, there. Okay. Our cosine function looks pretty similar, okay, to tangent, okay, to our basic tangent function, except it's shifted over a little and it's flipped. Okay. So it's reflected over the x-axis. So let's go ahead and look at cosecant. So cosecant is the same thing as 1 over sine. So the very first thing I'm going to do here is I'm going to do my table again. Okay? And once again, once you guys realize what these look like, you shouldn't have to use this table every time. Okay? You should just be able to draw this by knowing what these parent functions look like and what it looks like after. Okay, so let's go ahead and do our x's and for sine. So we're going to do, let's see, 0, pi over 2. Actually, let's go on ahead. We're going to include pi over 4. And then pi over 2. Then, let's see, is it 3 pi over 4? Okay, and then pi. And then we know that this is going to repeat on the other side. Okay, so that's going to give us, let's see, 3 pi over 2 and 2 pi. Okay. We're not going to do everything on the other side because I think once I show this to you, you'll see it and you'll get the pattern. Okay, so sine of 0 is 0. Root 2 over 2. 1. This is going to be negative root 2 over 2. Is it negative? Nope, it's positive. I lied. Okay. Pi is going to be 0. 3 pi over 2 is negative 1. And 2 pi is 0. Okay, so now to find cosecant, we have to put 1 over those numbers. So 1 over 0 is undefined. So now it looks like we have an asymptote right there. So now let's do root 2 over 2. So we're going to flip that. It's going to become 2 over root 2, which is really root 2, which is approximately 1.7. Okay, so pi over 4 is going to be about 1.7. Pi over 2 is going to be 1. 3 pi over 4 is going to be the same thing. So it's going to be 2 over root 2, which is approximately 1.7. And then pi is 0, so it's going to be 1 over 0. So that's another undefined. So it looks like our period is changing, but wait and let's see what happens here. Okay. So if we do 5 pi over 4, okay, we're going to get negative root 2 over 2. Okay, so here, if we did 5 pi over 4, we would get negative root 2 over 2, which would be approximately negative 1.7 once we flipped it. Okay, so that's going to be down here. Our 3 pi over 2 is negative 1. Where do you think this 7 pi over 4 would be? It's going to look like that. Okay, and then 2 pi is another asymptote. So now these graphs are just looking like this. But really, the cool thing about that is, let me draw the original sine function for you. So the original sine function looks like that. So really, it's parabolas taking off from the peaks, the highest and lowest parts of the sine curve, from the top of the crest. Okay? So if the amplitude changes, then it just means that where this takes off from changes. So let's take a look at cosine, and this time we're not going to draw a table. We're just going to draw our cosine curve. Okay, so our cosine curve starts here at 0, 1. It goes pi over 2, then it goes to -1, then it comes back up here. So here is my cosine curve, and I'm going to draw just a little bit more of it. So we're going to have the same thing here. For our cosine curve, we're going to have a function that looks like this. And pi over 2, okay, everywhere it touches 0, our cosine curve touches 0 is where our asymptotes for our secant curve are going to be. So the zeros of the cosine are the asymptotes. Oh, I put an extra t at the end. All right. Okay, so that is it for 2.2. Have a great day, and we will do 2.3 tomorrow.